Hello and welcome to this session on recursive functions. This video is aimed at someone who has never seen recursion before. So if you're fairly new to Python, if you're intermediate or whatever, but you've never seen recursion, then this video is probably a good one for you. There's plenty of videos which talk about recursion and kind of give a lot of fancy use cases, but in my experience this is one which people don't tend to get that well, and then suddenly it clicks. As a software engineer, we don't actually tend to use this a great deal in practice, if I'm honest. You could often achieve the same thing with just standard iterations using things like for loops or while loops, etc. But the point of this video is just to give you a really basic idea as to what recursion is. So I'm going to use a fancy kind of infographic, and then we'll do two really basic classic examples of recursion, showing you exactly what's going on. So the absolute basics of recursion is that, well, it's this. It's a function which has the ability to call itself. So basically you'll do a function call. Somewhere inside that function call, it's then going to call itself, and it'll keep going and keep going and keep going until something tells it to stop. And that's what we call our base case. So in some sense, think of a while loop, right? You've got a while loop which is going to say, while some condition is true, keep going until that condition is no longer true, and then stop. It's a little bit similar to that to some degree, except the base case basically tells you when to stop recursing or stop looping to some degree. Okay, here's my, well, not so fancy infographic. So suppose this is let's look at this big blue box here. So imagine this is your first function call. So you've defined a function, and this entry point, this black arrow, this is simply you saying, go and call this function. Okay. Now these orange arrows here, these represent recursive function calls. So basically what happens is you call the function once, you pass it in some stuff, and of course you're going to get some stuff back later on. But the recursive nature of that function basically means that the same function is going to be called again and again and again until some base case is met. Once that base case is met, we then basically we go back to our same entry point here, then you then get your result back. So that's kind of where the recursive nature means here. You know, we only call it once, but the function can then call itself, a certain number of times until some condition is met. We can then loop back to the beginning and we're happy. Probably worth noting here that Python does have a recursion limit of 1000, but if you import the sys module, you can actually make it go more than that. I mean, to be honest, if you're doing more than 1000, it might not be the best case for recursion. There might be a more efficient way. So without further ado, let's hop back into VS Code and take a look at a simple, practical example. Now, this first example is an absolute classic. If you look at any kind of recursive function tutorial, you're going to see this one. And this is the factorial of an integer. So to give you an idea as to what a factorial actually is, suppose you want factorial 6, often denoted like this mathematically. All it basically means, so if we wanted factorial 6, we're basically asking for the following. 6 multiplied by 5, let me make sure I said that right, by 4, by 3, by 2, by 1. So that's the factorial. It's some number, then you do multiplied by each number all the way down to 1 here. Now you can probably see this could quite easily be done using a for loop. We could say for each number between 6 and 1, keep hold of some kind of incremental number, and keep adding on the result of multiplication. So this is a kind of a good use case if you're a beginner. You could do the factorial version, you could do the iterative version, and kind of see what you prefer. But from a purely beginner point of view, I know it's a bit overdone, and yeah, it's a bit of a classic, but I think it's a great way to sort of see how this recursion kind of works from this point of view. So let's get started. I'm going to define a function called factorial, and I'm going to say that this takes in a single number n, which is an integer, and of course this is also going to return an integer as well. Now, what I want to do first is my base case, and in the vast majority of recursive functions, at least the ones I've seen anyway, you're going to see your base case right at the top here. So we're going to basically say, if n happens to be 1, let's stop return n. You can do return n or return 1. I'll do return n here. And this is our base case here. Think of this as like your get out clause. If you don't have this, basically what will happen is that it'll keep recursing and calling itself until you hit the recursion limit, and no one's going to want that. So what I'm going to do first, kind of controversially, I'm going to actually call it first, just like this, show you what's going on. If I did print factorial of 1, I'm going to hit Python 3 main.py, we get 1. Okay, so just something to bear in mind here. Let's go ahead and do 10. And we get none. Of course we get none because, you know, in this case n was 10, so this didn't fire, so in this case it's come down to here. So, and this is the bulk of where it's going to happen now. This is where it gets from very simple to very tricky in one go if you've never done recursion before. So we're going to say return n multiplied by, and here's the key bit, factorial of n minus 1. I'm going to quickly run this, check we're all good. Cool thing about factorial does that they scale up pretty ridiculously. I know factorial of 6 is 720, so I want to check this real quick. And there we go. So let's go through this because this suddenly got a whole lot trickier very quickly. So the base case wasn't hit for our first run because we passed in 6. So we said, okay, don't do this one, but come down to here and do return 6 multiplied by the same function, but pass in n minus 1, so pass in 5 instead here. So what I want to do is kind of almost like pseudocode our way through this. And before I do that, let's just quickly do something. Let's do value of n. We'll do this at the top here, just so you can kind of see the inner workings of this. And we'll hit run. I know this is, of course, you don't have to do this, but I think if you're learning recursion, this is quite nice because it kind of lets you see the value of the inputs going in. Of course, we've only done one function call. So you think of this as our entry point, and then the rest of these here, so the 5, the 4, the 3, the 2, and the 1, those are all of like the internal calls, so to speak, and that's all of this here. So we did this one, but then the function called itself here, and that's what made it recursive. So this little section here. So let's visualize, shall we? I'm going to clear the screen, and we'll do some comments to kind of show what this looks like, you know, from each of its recursive calls. Okay, so the way I want to do this is basically just talk through it and write comments to kind of explain what's going on here. So suppose 6, actually in fact, you know what, let's do a small one. Keep it really simple. Okay, so we're looking for 24 here. So factorial 4 is 24. So on the first run through, okay, 4 is not 1, so we didn't do this. So then we jump down to line 14, and we've said return n. So in this case, give me back n. So we are getting back n, which is 4, multiplied by, and then we're doing this again here. So imagine this case, so kind of, this is where it gets, I would argue, quite tricky because it's a little bit kind of invisible from this point onwards. So that's why I'm kind of doing it in these comments here. So get back 4 multiplied by, same function call again, n minus 1. So n minus 1, so 4 take 1 is going to be 3. 3 goes back into the function. 3 is not equal to 1, so we don't do this. So we're returning 3 times, we go again. So in this case we said 3, take away 1, so call the function again with 3 minus 1, so 2. 2 is not 1, so we do this. So 2 times, in this case now we're calling the function, and well, another time, factorial n minus 1. So 2 take away 1, it's going to be 1. So 1, and let's see, this is where the 1 goes back in. Okay, if n is equal to 1, yeah, it is. 1 is equal to 1, return n, 1. And there we have it. So we did 4 times 3 times 2 times 1. So this 4, this is kind of like from our original call. But then after that, we basically said go again with n minus 1, go again, until we did factorial n minus 1 where n was 2. And then we did 2 take away 1 to get 1. This hit our base case, and then we return 1. So therefore we did 4 times 3 times 2 times 1. So one more time, our entry point was here. We had a base case set, which basically makes us stop when we hit 1. And we're basically saying, keep on calling the function, passing in n with 1 less each time. Let me show you what happens if you don't do a base case. You'll get this recursion limit now. There you go. So see, we got this. If I scroll up a second, see this bit here? It's repeating. And it said the previous line repeated 993 more times. So basically saying it's recurs too much. Of course, you can override this if you import the sys module. But again, as I said earlier, I would argue that if you're recursing that much, unless you feel like a really specialist kind of binary tree operation, there's probably a more efficient way of doing it. So given this classic example, I want to go into another absolute classic, sort of classic job interview question. I want to look at how to reverse a string recursively. So I'll clear the screen and I'll be back in just a second with a fresh example. So just to reflect, the base case is what is going to stop the recursion here. In this case, our base case is simply going to be if an empty string is passed, return it. Okay. And I think what we'll do, we'll go through the code first on this, and I think this base case will become fairly obvious when we pass in an actual example. Right, so what I'm going to do first is define a function, reverse str, and we say reverse str takes st, which is a string, and it returns str here. Of course, your type ints are optional, but it's always kind of you can be 100% sure that it's going to be a string or etc. Always good to put them in, makes things a little clearer. So starting off with our base case, we'll say if st is indeed an empty string, go ahead and return it. You can do this or that, doesn't matter. I'll do st, just personal preference. And then next comes the actual recursive bit. So let's go through this bit nice and slowly. So I'm going to do return st and square brackets position 1 onwards, but this bit is actually going to be passed into our function again. So this is the actual recursive call here, plus st of 0 here. So of course this bit is making it recursive. If you think back to our factorial one, we said return the original number plus a recursive call of in our previous example it was n minus 1. This case here we're passing in. If we passed in hello, for example, we'd pass in lo back into the function. So what I'd like to do now is just quickly have a go at calling this. So I'm going to do print reverse str, and I'm going to pass in hello here. I'll do it all in the lowercase just for consistency. And there we go, that's come out backwards here. And I think what I want to do, just to kind of really hammer home how the recursive side of this is working, is, first of all, we're going to print off our STs here. There you go. And we're going to see basically how this is happening on a call-by-call basis. So I'll clear the screen, and below here I'm going to write in the comments exactly what is happening with our recursive calls and exactly how this string is being reversed. So if we envision our first run through, the string hello is passed in. The base case is not met because we don't have an empty string. So we're simply saying, basically return this plus this, okay? So if we take the hello and look at the plussing bit, so it's doing some part of the string plus st of 0. So st of 0, first character, h. So that means the rest of the string, the ello, is going here. Okay? Now, this bit here, this is our call, of course, our recursive call. So imagine this whole thing happening all over again, but with the ello. So kind of imagine this going to one side for a second. So ello, the first character, put to one side. So when I do this, it's going to be that eh, and the llo, bring this back in line, there. And of course the llo, that's our recursive call, one more time. So I'll do a plus here. And let's imagine this LLO now going back in. So ST of 0 for this, So the st of 0 is going to be L, and that's going to join our EH. So L, EH, leaving the L and the O on this side here. Get these back in line for us. And almost at the end of this one, so if you envision this now going back in, so the L and the O go back in for our recursive call. Let's line these up. St of 0 is going to be L, so the first character here. That's going to join these guys here. And of course no, not that one, that one. So now the O is now going to go back in. And now this is where the base case is going to be hit in just a second. So imagine the O goes back in. So in this case here, we've got st of 0. Well, there's only one thing left. So that's going to be O, LL, EH. And of course, when it tries to do st1 onwards, well, there's no string left. So that's where the base case is hit. The empty string is returned, well, the nothing string, and we get hello back here. So let's quickly bring these in. Let's hit this guy. So see how like these left-hand side bits here? There we go. They're passed all the way down until eventually we get our reverse string here. And that rounds up our video on recursion. And of course, just to reiterate a few key points, it's not something in the industry that you'll expect to be using all the time. Of course, the whole point of this video is just to show from a basic point of view kind of how it's done. We've looked at two examples, both absolute classics. You'll see them everywhere. We've done the factorial and a reverse string function. And don't forget, your recursive function, they generally have basically two bits. Your base case is really important, and that's basically what makes your recursive function stop. If you don't have this, you're going to end up hitting a recursion limit, which is not ideal. And of course, the second bit is going to be the part of your function. In this case here, it's this one here, the bit which actually goes off to do the recursive call. And just to kind of summarize, really, all a recursive function really is, it's a function like this, but that function has the ability to call itself. So in this case, we see function name here. The function name appears again in the same function. Hope this helps, and of course, if you're new to Python, I think this might be an ideal video to get you started with recursion. But yeah, cheers for watching, guys, and have a great rest of your weeks. Cheers.